Click the bell icon to get latest videos from Ekeeda.
Hello friends, so today we are here to learn about the eigenvalues and eigenvectors. In this particular video, we are going to focus upon geometric multiplicity and algebraic multiplicity of a particular eigenvalue. So in order to understand what is the algebraic multiplicity and geometric multiplicity, we should know the procedure of finding eigenvalue and eigenvector of a particular matrix. Suppose if we have got 2 by 2 matrix, we'll be getting 2 eigenvalues and 2 eigenvectors. If we have got 3 by 3 matrix, then we can have 3 eigenvalues and their respective 3 eigenvectors. Similarly, for n by n square matrix, we are going to have n eigenvalues and n eigenvectors. So, algebraic multiplicity and geometric multiplicity is defined for each and every particular value of an eigenvalue particularly. So, let us take an example and understand what it is. A is a square matrix of order n cross n. Therefore, there are n eigenvalues and n eigenvectors possible. Suppose if we take lambda 1, lambda 2, lambda 3 up to lambda n. These are n eigenvalues possible. If we consider lambda 1, the number of times any eigenvalue gets repeated is called algebraic multiplicity of that particular eigenvalue. For example, lambda 1 gets repeated twice, then the algebraic multiplicity is 2. If lambda 1, for example, lambda 1 is equal to 4 and it is getting repeated thrice, that is 4, 4, 4, then the algebraic multiplicity of particular eigenvalue lambda 1 is equal to 4 is 3. Suppose lambda 1 is getting repeated m times, lambda 1 comma lambda 1 to lambda 1 m times. Therefore we say algebraic multiplicity of lambda 1 is equal to m. Similarly, if lambda 3 is getting repeated n times, then we say algebraic multiplicity of, let's say example, lambda 3 is equal to, let's say, p times. So when we have got n eigenvalues and n eigenvectors, then we can have n algebraic geometric multiplicity together because it gets defined for each and every eigenvalue. Now let us focus upon what is geometric multiplicity. In order to understand what is geometric multiplicity, let's focus upon n by n square matrix. So in n by n square matrix, we are going to have n eigenvalues and n eigenvectors. Suppose a particular value lambda 1, it is giving birth to 3 or 4 or 5 number of eigenvectors together. In particular case, then we say geometric multiplicity is equal to 3, 4 or 5. That is nothing but the eigenvalue gives birth to how many linearly independent eigenvectors, and that decides the value of geometric multiplicity. In short, geometric multiplicity is nothing but how many linear independent eigenvectors can be born with particular eigenvalue lambda 1 or lambda 2 up to lambda n. Suppose lambda 1 is giving birth to 2 eigenvectors in each case. that is x1 and x2. Therefore we say geometric multiplicity of lambda 1 is equal to 2. That is, two eigenvectors it can give birth to and which are linearly independent. So let us understand algebraic multiplicity and geometric multiplicity by taking one particular example. So let us understand what is geometric multiplicity and algebraic multiplicity of an eigenvalue. Let us solve this problem and understand how it is calculated. So let us focus upon this problem. Find the eigenvalue and eigenvectors of matrix A and discuss about algebraic multiplicity and geometric multiplicity of each and every eigenvalue. And we know geometric multiplicity and algebraic multiplicity together is defined for each and every eigenvalue. So we know how to find the eigenvalue. Let us start with it. Let us start with the characteristic equation, which is mod of a minus lambda I is equal to 0. Mod of a minus lambda I is equal to 0 is the characteristic equation. Therefore, we are going to subtract lambda from each and every diagonal element. So we are going to have 0 minus lambda is minus lambda, 1 1, 1 minus lambda 1, and 1 1 minus lambda is equal to 0. And we have got formula for the same, which is nothing but lambda cube minus sum of diagonal elements into lambda square plus lambda into sum of minors of all diagonal elements minus mod of a, which is equal to 0. Therefore, lambda cube minus sum of all diagonal elements. I can see 0 0 and 0, and that is what the addition is all about, into lambda square plus lambda into sum of minors of all the diagonal elements. So let us focus upon this 0. I leave this row and this column and I am left with 0 1 1 0. So that is 0 into 0 minus 1 into 1, which is minus 1. Let us focus on this 0. I leave this column, this row, and I am left with 0 1 1 0. It is again 0 minus 0 0 and 1 into 1 minus 1, which is again minus 1, plus let us focus on this. I leave this column and this row and I am left with 0 1 1 0, which is 0 into 0 0 minus 1 into 1 1. So 0 minus 1 is minus 1, minus the mod of a. Mod of a is nothing but 2, which is the determinant value. If you put this into calculator, you will get the value as 2. Therefore, the equation becomes lambda cube, this is absolutely 0, and this is minus 3 lambda minus 2 is equal to 0. If you solve this particular equation by using calculator, you will be getting the value of lambda is minus 1, minus 1 and 2. That means this is 3 by 3 square matrix and there will be 3 eigenvalues, minus 1, minus 1, 2, out of which minus 1 is getting repeated twice. So we have got minus 1 and 2 are the eigenvalues of the matrix A. Now let us find out the eigenvectors of the same. lambda is equal to -1 is the first eigenvalue which has been repeated twice. So we say the algebraic multiplicity of lambda 1 is equal to -1 is equal to 2 because it has got repeated two times twice. Therefore, algebraic multiplicity of lambda is equal to -1 is 2 because it has got repeated twice. So let us find out what is the eigenvector which we are going to obtain. Therefore, a minus lambda I into x is equal to O. It is the characteristic equation. Therefore, we are going to subtract a minus lambda into I, which is -1, from all the diagonal elements. We know all the diagonal elements are 0, 0, 0. So we are going to subtract -1, -1, -1 from the same, and I am going to get 1, 1, 1 as the diagonal element. As we can see, 1, 1, 1, 1, 1, 1 and 1, 1, 1 into x1, x2, x3 gives the same equation, which is x1 plus x2 plus x3 is equal to 0. So I'm going to write down x1 plus x2 plus x3 is equal to 0. Now let us understand, number of unknowns in this particular equation is equal to 3. That is x1, x2 and x3, and number of equation we have obtained is equal to 1. Therefore, number of parameters which we'll require is equal to 3 minus 1 is equal to 2. So let's take two parameters, that is s and t. Let us consider x2 is equal to s and x3 is equal to t. Therefore, x1 plus, we'll put the values over here, we'll put s plus t is equal to 0. Therefore, x1 becomes minus s minus t. S goes here, t goes here. It is minus s minus t. Therefore, vector x1 is equal to minus s minus t, which is x1, x2 is s and x3 is t. So I can write like this, minus s minus t. S plus 0, it is going to be the s, and t as 0 plus t. Now you can see this is the addition of two vectors. First row separately I'll write down minus s and 0 plus this second column, which is minus t, 0 and t will write down. Now I am going to take s common and t common and put the values of s and t as 1, and we'll see what we get. We have s common, so I am going to have minus 1, 1, 0, and if we have t common, I am going to have minus 1, 0, 1. Now we put s is equal to 1 and t is equal to 1. We get x1 as minus 1, 1, 0 and second vector x2 as minus 1, 0 and 1. As we say, it has given birth to two vectors x1 and x2, and this is nothing but the geometric multiplicity. It is defined as the how many linear independent eigenvectors giving birth by the particular eigenvalue. Now eigenvalue which we had selected was lambda 1 is equal to minus 1, and it has given birth to these two x1 and x2, these two eigenvectors. Therefore, we say geometric multiplicity is equal to 2 and algebraic multiplicity is also equal to 2 because it has got repeated twice. Now let us focus on the remaining eigenvalue, which is lambda is equal to 2. Now since lambda is equal to 2 has got repeated only once, so the algebraic multiplicity is equal to 1. In case 2, we have got lambda is equal to 2. Now lambda is equal to 2 has got repeated only once. Therefore we say the algebraic multiplicity of lambda is equal to 2 is equal to 1. Now let us focus on characteristic equation, which is a minus lambda I into x is equal to O. So we are going to subtract lambda is equal to 2 from all the diagonal elements of A. So let us focus. We have got 0, 0, 0 in the diagonal element. So I am going to subtract 2, 2, 2, which is minus 2, minus 2 and minus 2. So let us focus on the same. Into x1, x2 and x3 is equal to 0, 0 and 0. Now it is giving birth to three equations. Minus 2x1 plus x2 plus x3 is equal to 0. Second row and column, x1 minus 2x2 plus x3. And the third one, x1 plus x2 minus 2x3 is equal to 0. Now in order to solve this equation, we'll use Kramer's rule. In Kramer's rule, we are going to take two distinct equations and apply the Kramer's rule. By Kramer's rule, we have x1 divided by 1 determinant is equal to minus x2 divided by 1 determinant is equal to x3 divided by 1 determinant. Now let us focus on the equations. Equations we have taken, first two equations we have taken. Now in order to write x1, we'll hide x1 and we'll be having 1, 1, minus 2 and 1 as my determinant. While writing for x2, I'm going to have minus 2, 1, 1 and 1. While writing for x3, we are going to hide x3 and I'm going to have minus 2, 1, 1 and minus 2. So let us write down. And we'll equate this as k. So let us solve this determinant. 1 into 1, 1 minus minus 2, which is 1 plus 2 is equal to 3. Therefore, x1 divided by 3 is equal to minus x2 divided by minus 2 into 1 is minus 2 minus 1 minus 1. So which is minus 3 is equal to x3 divided by minus 2 into minus 2 is 4. 4 minus 1 into 1 is 1. So 4 minus 1, 3 is equal to k. Therefore, x1 is equal to 3k. Minus and minus sign will go and we'll be having x2 is equal to 3k. And we'll having x3 as 3k. Therefore, eigenvector x3 is nothing but x1, x2 and x3 as 3k, 3k and 3k. I'm going to take 3k out. So we'll be having 1, 1, 1. Now we'll put k is equal to 1 by 3. If we put k is equal to 1 by 3 over here, 3 into 1 by 3 is 1 and therefore x3 is going to be 1, 1, 1 and that is nothing but the third eigenvector. Now since lambda is equal to 2 is the particular eigenvalue. It has got repeated only once, so algebraic multiplicity of this particular eigenvalue is 1, and geometric multiplicity of this eigenvalue is also 1 because it has given birth to only one linear independent eigenvector, which is nothing but x3, that is 1 1 1. Therefore geometric multiplicity is equal to 1, and algebraic multiplicity was also 1. So we have calculated geometric multiplicity as well as algebraic multiplicity using one example, that is 3 by 3 matrix. Thanks for watching this video. Stay tuned with Ekeeda and do subscribe to Ekeeda.